Throughout the vast expanse of time, certain names resonate with unparalleled significance, their echoes reverberating through the corridors of history. Consider Archimedes, the ingenious mathematician and inventor, Newton, the father of classical physics, and Galileo, the pioneering astronomer who dared to challenge the established order. These figures represent milestones in our understanding of the universe. And then there is Einstein. His name is now a synonym for genius, instantly recognizable across cultures and generations, his face an icon worldwide. But what did he do to earn such a place in our collective imagination, to be elevated to such a legendary status? What were the groundbreaking ideas that cemented his legacy? He wasn't a king, wielding power and commanding armies, or a conqueror, amassing territory through force and domination. He was a thinker, a dreamer, armed with nothing more than an insatiable curiosity and an unwavering dedication to unraveling the mysteries of the cosmos. Einstein dared to question the very fabric of reality, challenging long-held assumptions and pushing the boundaries of human knowledge. The universe, once seen as a grand clockwork, a perfectly ordered and predictable machine, was comfortable and predictable until Einstein arrived on the scene, ready to shake its foundations. He saw a universe far more mysterious and wondrous, a place of infinite possibilities and mind-bending phenomena than anyone had previously imagined. He revealed that space and time are not separate and absolute entities, as previously believed, but woven together into a single dynamic continuum, space-time. This journey of discovery began not in a grand observatory equipped with cutting-edge technology and staffed by legions of researchers, but in the seemingly mundane setting of a young patent clerk's office in Bern, Switzerland. Without powerful instruments or the backing of a prestigious academic institution, he relied solely on the power of his imagination and an unrelenting drive to understand the universe. Through ingenious thought experiments, he fearlessly challenged conventional wisdom and rewrote the fundamental rules of physics. In doing so, he irrevocably changed our view of the cosmos, ushering in a new era of understanding. It's a story of perseverance in the face of skepticism and a testament to the transformative power of questioning everything we think we know. So let's travel back in time, not just to understand the complex science, but to delve into the life and mind of the man behind it all. We'll explore the pivotal chapter in his life where he conceived his revolutionary theories of relativity, forever altering our perception of space, time, gravity, and the universe itself. This is more than just a historical account. It's a testament to the extraordinary potential of human curiosity and how one person's relentless pursuit of knowledge can unlock the universe's deepest secrets. Perhaps the most powerful force in the entire cosmos isn't a supernova or a black hole, but a single, curious human mind, driven by an insatiable desire to understand the world around us. Every great journey begins with a single step, a moment of inspiration, a spark that ignites the flame of curiosity. Our story, the story of a mind that reshaped our understanding of the universe, begins with just such a simple yet magical moment. It happened in young Albert's life, a pivotal point that would set him on a path of discovery and innovation. This moment, seemingly insignificant at first glance, would prove to be the catalyst for a lifetime of groundbreaking work. Picture 5-year-old Albert, a small boy in the bustling city of Munich during a time long past. Imagine the cobblestone streets, the horse-drawn carriages, and the grand architecture of 19th century Munich. He was confined to his bed, sick and restless. His small world shrunk to the 4 walls of his room. The vibrant city outside seemed a distant dream. Then his father entered the room and handed him a simple, unassuming object, a pocket compass. A small gesture, perhaps, but one that would change the course of history. To most children, a compass might be just another toy, a trinket to be played with and then forgotten, something to briefly occupy their time. But for Albert, it was far more than that. It was a revelation, a window into a world of unseen forces and hidden mysteries. He watched, mesmerized, as the needle, seemingly guided by an invisible hand, danced and twirled, always settling back to point in the same direction. No matter how he turned the compass, the needle stubbornly, consistently, always points north, an unwavering guide. Why did it do that? What unseen power was at play? This simple question, born from a child's observation, planted a seed of deep curiosity in Albert's young mind, a seed that would blossom into a lifelong pursuit of knowledge. The compass, in its own silent way, showed him that the world was not just what it seemed on the surface, but was filled with hidden forces, unseen connections, and profound mysteries waiting to be unraveled. Sadly, the rigid structure of school didn't appreciate his burgeoning curiosity. The teachers, focused on rote memorization and strict discipline, often saw him as slow, inattentive, and even rebellious. They struggled to contain his inquisitive spirit, but at home he found solace and encouragement, especially from his insightful and supportive uncle. Driven by his insatiable thirst for knowledge, he devoured books, immersing himself in the worlds of math and science, seeking answers to the questions that burned within him. In particular, Euclid's geometry became his holy little geometry book, a source of endless fascination and inspiration. It revealed to him the elegance and power of pure thought, the ability to deduce profound truths from simple axioms. The compass had revealed the existence of invisible forces shaping the world around him. Geometry, in turn, revealed the existence of absolute truths, immutable laws governing the universe. These two seemingly disparate elements, a sense of wonder and curiosity about the mysteries of the world, and an unwavering faith in the power of reason and logical deduction, together became the bedrock, the very foundation upon which he would build his life's work, his revolutionary theories, and his enduring legacy. In essence, the scientist, the visionary, was born not in a laboratory or a lecture hall, but the moment a curious child peered behind the curtain of the everyday world and dared to ask, why? As a teenager, Albert's questions grew bolder. The compass's mystery led him to the greater mystery of light. Maxwell had shown light was an electromagnetic wave, always traveling at the same speed, c/t. But how could the speed of light be the same for everyone? At 16, Einstein asked, what if I could ride on a beam of light? If you raced alongside a light wave, would it freeze beside you? Maxwell's equations said no. This paradox haunted Einstein. Newton's laws and Maxwell's laws couldn't both be right. The problem wasn't with light. It was with our rigid ideas of space and time. They were the concepts that had to bend. This single question became the obsession that would change physics forever. After Zurich Polytechnic, Einstein struggled to find an academic job. He landed at the Swiss Patent Office, a blessing in disguise. Reviewing patents about clocks and signals, he thought deeply about time and simultaneity. The Patent Office became his sanctuary, his mind free to roam. He formed the Olympia Academy with friends debating science and philosophy. In this humble setting, his most creative ideas took shape. As an outsider, he was free to think differently. His desk became his laboratory, his mind the experiment. The questions of light, time and space simmered beneath the surface. The world had no idea a revolution was brewing in Bern. 1905. A year etched in the annals of scientific history. A time when the world was on the cusp of profound change, little did it know what lay in store. It was Einstein's miracle year, a period of unparalleled intellectual output that would forever alter our understanding of the cosmos. A young, relatively unknown physicist, toiling away in a Swiss patent office, was about to unleash a torrent of revolutionary ideas. At just 26 years old, he published not one, but 4 groundbreaking papers, each a masterpiece in its own right. These weren't mere incremental advancements, they were paradigm shifts that challenged the very foundations of classical physics. And remarkably, he accomplished all of this while working full-time, juggling his intellectual pursuits with the mundane realities of a day job. It's a testament to his extraordinary dedication and focus. The first paper provided compelling evidence that atoms and molecules were not just theoretical constructs, but tangible realities. It was a crucial step in solidifying the atomic theory of matter. The second paper introduced the concept of the photon, a discrete packet of light energy, laying the foundation for the revolutionary field of quantum mechanics, which governs the behavior of matter at the atomic and subatomic levels. The third, titled On the Electrodynamics of Moving Bodies, birthed the theory of special relativity, forever changing our understanding of space and time. He elegantly solved the perplexing light beam paradox with just two deceptively simple postulates. First, that the laws of physics are the same for all observers in uniform motion, regardless of their relative velocity. And second, that the speed of light in a vacuum is constant for all observers, irrespective of the motion of the light source. The consequences of these postulates were profound. Time slows down at high speeds, a phenomenon known as time dilation. Space contracts in the direction of motion, a concept called length contraction, and time itself is revealed to be relative, not absolute, as previously believed. Imagine an astronaut traveling near the speed of light. According to special relativity, they would age significantly slower than their twin, who remained on Earth, a mind-bending concept known as the twin paradox. In that same year, he also revealed the fundamental relationship between mass and energy, encapsulated in the iconic equation A = mc2. This equation demonstrated that even a tiny bit of mass, when converted into energy, could unleash an absolutely enormous amount of power. After Einstein's miracle year, the universe and our understanding of it would simply never look the same again. Special relativity was monumental, but incomplete. It didn't include gravity. For 10 years, Einstein sought a theory that would. His happiest thought, a man in a box can't tell if he feels gravity or acceleration. This principle of equivalence was the key. Gravity, he realized, wasn't a force pulling objects, but the warping of space-time by mass and energy. Massive objects curve space-time. Planets follow these curves. Years of struggle and new mathematics led to his general theory of relativity. In 1915, he presented equations showing how matter shapes space-time. It was a new law of gravity, a dynamic geometric vision of the cosmos. The universe was now a dance between matter and the fabric it inhabits. General relativity was beautiful but needed proof. It predicted gravity could bend light. During a total solar eclipse in 1919, astronomers could test this. Sir Arthur Eddington led expeditions to observe starlight near the sun. Clouds threatened, but the sky cleared just in time. The results: starlight was bent exactly as Einstein predicted. Headlines declared Newton's universe overthrown. Einstein became an international celebrity overnight. His abstract theory was proven by the stars themselves. The world saw the universe in a new light. General relativity didn't just make Einstein famous, it transformed our understanding of the universe. The static, clockwork cosmos was gone now. Space-time could bend, ripple and stretch. The theory predicted black holes, once thought fantasy, now proven real. We photographed a black hole's shadow and know they power quasars. The universe, Einstein's equations showed, must be expanding. Hubble's discovery of receding galaxies confirmed it. The Big Bang was born from Einstein's math. Today, relativity is essential for technology. GPS wouldn't work without it. Satellites experience time differently. Engineers must correct for relativity. From cosmic scales to our phones, we live in Einstein's universe. His ideas are the operating system of our reality. Einstein's story is more than scientific discovery. It's a lesson in curiosity. It began with a child's wonder at a compass and a teenager's dream of riding a light beam. His questions weren't for fame or fortune, but to understand the world's deepest mysteries. He faced rejection, isolation and skepticism, but never gave up. His journey shows that breakthroughs come from basic questions and relentless pursuit. Einstein's true legacy is an invitation to look up, to wonder, to question. The universe is stranger than we can imagine, and curiosity is our guide. One person, one question can change reality. The journey of discovery is open to us all. The most powerful tool is a curious mind willing to ask, what if?